This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on proving trigonometric identities. We want to prove that 1 plus tan squared theta is sec squared theta. And this is a direct consequence of the fundamental trig identity. That, of course, is that cosine squared theta plus sine squared theta equals 1. Now, knowing that, we can divide everything by cos squared. So cos squared theta divided by cos squared theta, sine squared theta divided by cos squared theta, 1 divided by cos squared theta. Cos squared theta divided by cos squared theta is 1. Sine squared theta divided by cos squared theta is tangent squared theta, because sine theta over cos theta is tangent. 1 over cos squared theta is secant squared, because 1 over cos is secant. So starting with an identity we know, dividing everything by cosine squared theta, we get the identity we're looking for, and we've done the proof. That's sort of our simplest kind of identity to prove. Now in this case, I want to take a look at sine theta over 1 minus cos theta and prove that that's 1 plus cos theta over sine theta. On these more complex identities, I suggest you start with one side of the equation and have a string of equal signs to get to the other side of the equation. More often than not, the left-hand side is more complicated, so I'm typically going to make that choice. So the left-hand side is simply sine theta over 1 minus cos theta. I want a string of equal signs to get to the right-hand side. Well, I need to do something to change this to make it look like that. And the strategy I'm going to use is I'm going to multiply the numerator and the denominator by 1 plus cosine theta. Of course, 1 plus cos theta over 1 plus cos theta would divide out. It's just 1. I am not changing the value of that original fraction. I'm just making an equivalent fraction. Distributing, first getting sine theta times 1 plus cos theta over 1 minus cos theta times 1 plus cos theta. Distributing here, well, actually I'm not going to distribute here. I'm going to go ahead and multiply those guys. 1 minus cos theta times 1 plus cos theta is 1 minus cosine squared theta. 1 times 1 is 1. Negative cos theta times 1 is negative cos theta. 1 times cos theta is positive cos theta. Those cancel. Negative cos theta times cos theta is negative cos squared theta. But what do we know? From Pythagoras, we know 1 minus cosine squared theta is the same as sine squared theta. So making that Pythagorean change, sine theta over sine squared theta will just leave me with the sine theta downstairs. And notice 1 plus cos theta over sine theta is my right-hand side. So we go ahead and we have it equal to the right-hand side. So this is the general strategy to use. Start with one side of the equation, equals, 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 get the other side of the equation. That really is the best way to go ahead and prove these more complicated identities. Let's look at another one. Tangent squared x plus 1 plus tan x sec x is 1 plus sine x over cos squared x. You want to start with the side that is more complicated. The left-hand side seems more complicated. So we're going to look at the left-hand side, tan squared x plus 1 plus tan x sec x. Well, what do we know? 1 plus tangent squared x is secant squared x. That we just proved earlier. Sine x over cosine x is tangent x. 1 over cosine x is secant x. That may be enough for me to get started on the problem. So indeed, tangent squared x plus 1, secant squared, tangent x, sine x over cos x, sec x, 1 over cos x. Where to next? Recognizing secant squared x is 1 over cosine squared x. Multiplying this fraction, sine x times 1 is sine x, cos x times cos x is cos squared x. So now you'll notice we have a common denominator. The common denominator is cosine squared x. And I have 1 plus sine x over cos squared x, which is the right-hand side. Starting with the left-hand side, this value equals, 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 equals the right-hand side, and we have proven the identity. Let's take a look at this one. Sine of a plus b over cos a cos b equals tangent a plus tangent b. To do this, I'm going to need to use the identity of sine of a plus b. That's sine a cos b plus cos a sine b. So keeping that in mind, We also want to start with one of the sides of this identity. The left-hand side looks more complicated, so I'll start with the left-hand side of sine of A plus B over cos A cos B. Then using that identity I just mentioned, sine A cos B plus cos A sine B, making that substitution for sine A plus B, we're here. Now I have a common denominator. I'm going to actually split this up and say sine A cos B over cos A cos B plus cos A sine B over cos A cos B. Where will that send me? Here. And you'll notice that we have some cancellation. The cos B's cancel in this first fraction, the cos A's in the second, which gives me sine A over cos A plus sine B over cos B. Well, sine A over cos A is just tangent of A. Sine B over cos B is just tangent of B. So we go ahead and get the tangent A plus tangent B, which is the right side of this identity. So again, you'll notice the process. Left-hand side equals, 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 equals right-hand side for us to verify that identity. Well, here is a more complex one. 1 over tan theta minus sec theta plus 1 over tan theta plus sec theta equals negative 2 tangent theta. So the strategy is going to start with the more complex side, which again is the left-hand side. So we're going to write the left-hand side that way. And we need to think about how we're going to proceed. And when in doubt, it's often good just to convert everything to sines and cosines. Sine of theta over cosine of theta is the same as tangent theta. 1 over cos theta is secant theta. Similarly, sine theta over cos theta is tangent theta. And 1 over cos theta is secant theta. So I can write it this way. Now this is a little challenging because I have fractions over fractions. But just kind of ignoring the top for now, what can we do with the bottom for us to understand this? We recognize you have a common denominator here of cos theta. So I can rewrite this as sine theta minus 1 over cos theta for this first piece. Sine theta plus 1 over cos theta here. 1 divided by sine theta minus 1 over cos theta. A fraction 1 over 1 divided by this fraction will require us to invert and multiply. That would be 1 times cos theta over sine theta minus 1. Similarly, 1 times invert and multiply cos theta over sine theta plus 1. So doing the division carefully, we just get cos theta over sine theta minus 1 plus cos theta over sine theta plus 1. Let me correct that. So indeed I've made that correction. Sine theta minus 1 over cos theta, sine theta plus 1 over cos theta, which then will give me cos theta over sine theta minus 1 plus cos theta over sine theta plus 1. Now how do we add the fractions? This times this, cos theta times sine theta plus 1, plus this times this, cos theta times sine theta minus 1, over this times this, over sine theta minus 1 times sine theta plus 1. So doing the algebra, we get to this point. Now distributing cos theta sine theta plus cos theta, distributing here cos theta sine theta minus cos theta, you'll notice that we have some cancellation. So what happens here? The cos thetas go away. Cos theta minus cos theta, leaving me 2 cos theta sine theta over sine squared theta minus 1. Well, we're not finished with this. We have some more work to do, so let me go ahead and grab that last line. We're trying to prove this, and here's the last line that we had from the previous page. Continuing, losing the cos thetas and adding these together, we get 2 cos theta sine theta over sine squared theta minus 1. Now this should indicate something. We know 1 minus sine squared theta is cos squared theta, but I don't quite have 1 minus sine squared theta. I'd like to get it. To do that, I'm going to factor out a negative 1 and recognize that sine squared theta minus 1 is the same as negative 1 times 1 minus sine squared theta. Once I'm here, 1 minus sine squared theta is cos squared theta. So I have 2 cos theta sine theta over negative cos squared theta. Now what happens here? One of these cosines knocks out one of these, giving me 2 sine theta over negative cos theta, or to make it a little simpler, moving that negative sign up to the numerator. Now what is sine theta over cos theta? Sine theta over cos theta is tangent theta. And that goes ahead and gives us that answer of -2 tangent theta, which is indeed the right-hand side of our original that we were trying to prove. So our strategy was to start on the left-hand side and have a whole string of equal signs so that our result will be the right-hand side. And that will conclude this lesson.